ready? Okay, we're going to get started. I'm told that we're starting late because of the keynote, but that we don't have to cut short, and the next session will be regular time. They're cutting on lunch, so thank you for coming here. How many people were at my talk yesterday, the overview talk? Wow, and you came back for more? I'm impressed. One thing I found interesting yesterday was a few people said they liked my talk, which I found really interesting. But my real point was I asked them, oh, really, if you liked it, would you mind filling out a survey? And people said, survey? I haven't filled out a survey all day. We do use those to figure out whether the content we're giving you is good and whether if we do this again, we should continue with that kind of content. So those surveys are useful, and if you don't, how many people don't know how to do a survey? Okay, so on the back of your badge, there's a website address for downloading a tool, and the guide also tells you how to do it, but it's all online, and it's fairly painless, and we would appreciate it if you fill those out. I have a few more benchmarking questions. I did this yesterday, and it just helps me gauge the people who are putting up with me today. How many people have ever run a benchmark? Raise your hand. Okay, much more than yesterday. Okay, how many people have run a benchmark in the last year? Almost everyone, so that means you're active. How many people have run a benchmark in the last month? Okay, slackers. Oh, good, good. Okay, last week? How many are running a benchmark as we speak? Okay, I am. Plenty of that. That's good. Great. Okay, I am not going to go through. Yesterday, I did a practical demonstration of benchmarking to illustrate a few important points. I am not going to do that, but the reason I'm bringing this up is I have some really good dark chocolate M&Ms. And after the talk, if you'd like some, I don't want to carry 1.5 pounds of M&Ms back. So I would appreciate it if you would help me out by getting rid of eating some of these. It's a dispenser. That means no one else has touched them, so you get a handful and it's good. The benchmark was the question I started with, because one of the important things about benchmarking is if you want to do it well, you have to have a precise question you're trying to answer. My precise question yesterday was how many M&Ms are in here? And I went through a couple different ways you could answer that. You could count them one by one. You could use measuring cups. You could use 2 measuring cups to do the least amount of measurements, but that introduces error, that sort of idea. The goal for today is for me to give you some practical tips based on my experience doing benchmarking on AWS. I'll give you some, I'll go over some results that I've measured recently. And give you some tips if you are going to benchmark on how to do it. I tried to strike the right level of balance with giving you actual data and giving you tips, and there's a little bit of overview material. There's a very small amount of overlap with the content I did yesterday. I'll use a couple slides that have the similar data, but I'll go into more detail about that data and how I got it. The timing that I have for this is fairly good, so if you have a burning question while we're going, and that question seems like it won't get me off track too far, go ahead and throw up your hand. If I'm on a roll and I want to take it at the end, please hold that question till the end, and then I will take questions at the end. And if we're tight on time, I will take them outside or at lunch. I don't know how you would find me at lunch. Maybe I'll bring the M&Ms and hold it up or something like that. Okay, so enough of that. So there are lots of questions that I hear and come across in AWS. Some of them are general, like how do I find a bottleneck? Some of them are very specific. With DynamoDB, for instance, we have a very interesting statement that DynamoDB provides single millisecond service-side latency on average. No, we don't say on average. Typically, single-digit millisecond service-side latency. The real question is, what does that mean for my clients? And that's one I've heard. What AMI should I use? That's a question people should ask more that they don't. And what instance will give me the best cost performance? Another one for prospective customers is how will my app in the data center run or on premises run on AWS? I do have one answer that I'm absolutely certain is completely appropriate for all of these questions, and that is, it depends. I made this point yesterday, and it may sound like I'm being flippant, but the reality is most questions that I see are rarely precisely formed enough that you should give a precise answer. The precision of your answer should be directly proportional to the precision of the question. So if you get a general question, the first thing you have to do, you can say it depends if you want, or you can say it in your head and then ask a bunch of qualifying questions. Because in order to give an answer that really matters, you have to know more about what... I like to answer with things that can be measured. And when you're going to benchmark, you really want to have specific questions to answer. So I thought I would start with some generalized pearls of wisdom. Maybe it's egotistical of me to think they're pearls. I think they're useful. The first one is simplify your tests. I have an architecture diagram that sort of has all the best bits and services strung together in a very elegant architecture. But when you look at that diagram, it's pretty darn complicated. And typically when you're trying to benchmark, you're either trying to baseline something or you're trying to improve it. If you're trying to improve it, it's pretty complicated when you do the whole thing at once, and it sometimes really helps to break it down into component parts. So simplifying tests is not specific to AWS, but I typically find it helps a lot. Another thing from years of experience, save all of your log files in S3. It's really easy to do, and I can't tell you how many times I am asked to run a test where I know I've run something like this before. Wait a minute, I've got logs that I can go back and look at. Or that you come up with some interesting phenomenon and you need more data and you realize you already have that data. Keeping logs around becomes really useful. Beyond that, being able to do queries, particularly if you're doing historical analysis, is really useful. I tend to put all of my results in an RDS database, and I have a schema that I've worked out over the years that essentially generalizes experiments, and it allows you to bunch different experiments into sort of a grand experiment and do variance and everything. But I can't tell you how many times being able to just do a simple SQL query or even dump things into a spreadsheet and look over results can let you produce impressive graphs. When someone says, what's our standard deviation over the past year? And they think they're going to make you go off and run tests, and you go off and just run a query, and that's a lot more useful. You want to monitor. And this isn't, in AWS, CloudWatch has an amazing number of metrics that you can use. But one of the things you want to watch for is that you're not measuring errors. And there are all sorts of errors that can happen, whether they're application errors, whether you're hitting throttling limits. And the last, I won't demonstrate, but you know the hitting your forehead? I can't tell you how many times I've done that, and maybe that's something about me I should work on, but where you suddenly look at data and you say, oh, that's why that's happening. And having monitoring errors is really important, or monitoring in general. I'll have some special comments about measuring provision services. The main reason why is provision services are, you're pre-declaring how much capacity that you want. And in order for us to ensure that you get the capacity, we put in limits to make sure if you go over your capacity that we throttle you in some way. The problem is that if you don't realize you're going over that and you're hitting a throttling limit, you may have some extra latency that you hadn't thought about. Be sure you're not measuring your tests. This may sound vague, but I've seen a lot of instances where people had either tests that were built by someone else or their own tests that had their own problems. If you're trying to get answers, the last thing you want is for the tools that you're using to complicate those answers. So you really have to trust your tools. Automate and use good AMIs. I don't really need to say a whole lot about automate, but I will say some more about using good AMIs. I use this slide, this is from yesterday, but I think this is an important point I want to make. Not all AMIs are the same. There are very clear guidance on, there is very clear guidance on AWS around using precaution in using AMIs. Most of it centers around security, but I also have to tell you from a performance perspective, there are public AMIs out there that are not very good. And when I mean not very good, they don't perform well. Typically, my investigation has found most of these have really old kernels. This particular test, these were all run on M2 4XLs. The exact same test, CPU test was used. It was a relatively simple test. No parameter settings that were different. The first 4 results, going from top to bottom, are all running on the same CentOS release, 5.4. The bottom two are one is an AWS AMI, and the second one is the official Ubuntu 12.4. These two have what I would call good results, and I mean good because they were reproducible, they're reliable, and they make sense for me when I run them on other instances. These other three did not. Now these numbers don't look that bad, but if you look at the relative standard deviation, if you're not familiar with relative standard deviation, I like to use that rather than standard deviation because it's the average divided by standard deviation. So it gives you something in units that are percentages. So this says that the relative standard deviation was up to almost 60%, meaning on some of the poorest performing AMIs, I would see results ranging from 9 up to 20. And that's running just 3 tests. So be very careful if you're trying to do performance work that you actually start with an AMI that you can trust. If it's not one that you built yourself, then you should probably try to run some tests to see if it is part of your issue. There are really 3 ways that you can use benchmark results, and the recommended way is to use benchmarks that are as close to your application as possible. You can also run standard benchmarks, and you can use published results. I'm going to really concentrate on these first 2. I spent a lot of time yesterday in the overview talk talking about using published results. This is that diagram I was talking about. This is a sketch of a well-formed AWS taking advantage of security groups and availability zones and lots of services. But if you look at this diagram and you think about where bottlenecks could occur or where latency time could be spent, there's a lot of surface area here to try and test. My first approach to this diagram would be to simplify it and eliminate some of the peripheral services so that you get down to the things that are most likely to be major contributors to, for instance, if you're doing end-to-end testing, page load time. Why? Well, certainly things that have to go to disk are going to take longer than things that are traveling at the speed of light. And so anything that touches a disk is a likely thing to measure. Anything that has queues or could have queuing or could involve locks is a likely thing to look at. So I'm going to go into a little more detail about how you would benchmark your own application. It sounds simple, but if you've ever thought about, okay, this app has been built, we've never really run a benchmark, where do we start? I would always start with choosing the workloads. And how you choose a workload is, there are a variety of choices. You could choose the features that are most important. You could choose the features that are used most often. You could choose the features that are most popular. One of my favorites, you could choose the ones for which you get the most complaints. You could get the ones that the person who has business control over the application uses most often. Therefore, the most important person with respect to the project, you want to make them happy because then nothing else matters. Or you could, from data you have, look at the worst performing. But a workload is a subset of all of the features and functions. And it's typically not as simple as we're just going to run, sign in a new user. It's going to be a combination of sign in a new user and authenticated users logging in and, say, in a web environment, catalog lookup or order lookup or something like that. That's a workload mix. And it usually helps to define that mix with a ratio so that you say, typically at any one point in time, there are 5% of this, 10% of that, and so on. Now, this sounds like a lot of trouble, but remember my earlier point that you need precise questions in order to give precise answers? Getting to this level of precision gives you something you can measure. And the assumptions may be all wrong. You could get the workload mix completely wrong. But it's easy to go back and change a workload mix and then run the test again. Having this format makes it easy. Now, I like to think of the workload before setting targets, and it's really important you set targets. Yesterday I talked about this too. Setting targets is really important for 2 reasons. I have a slide about that, so I won't go into that. You need to know when to stop, etc. If no target exists, I hear this question a lot. Well, how do I know what targets to set? You could just make one up. Doing this process is always iterative. So you set one, say, boy, that was really wrong. I said, single millisecond latency, and there's no way I can load a page in single megaseconds. That was wrong. Let's get something that's closer to real. Or you can measure whatever it currently is now and say, this may not be what I want, but I'm going to just set this as my target. Make sure I run tests that can repeatedly hit this target, and then I can work on improving it. You can't tune something that you can't generate predictable load for. So setting predictable load is really important. Baselines are really important. That's the whole analogy with measuring M&Ms. The baseline, for instance, for estimating might be to fill a 2-ounce cup, count how many in here, and then extrapolate how many 2-ounce cups fit into this, and you can get a pretty good estimate fairly close by having a baseline of how many M&Ms are in a cup. You can look for targets that someone else uses. This is a common practice in web apps I've found, is that people go around and say, well, what does Target say about what their client latency should be? Or there are lots of empirical studies. I think there have been some blog posts about what's a good response time for users. It's almost, I'll know it when I see it kind of thing. There have been lots of detailed studies that show, a half second of latency can mean the difference between people abandoning a page and not. My point here is that you really need to set targets. And even if you have to guess, you iterate, you set a target, you see if that's relevant, and then you go from there. I want to bring up Sisyphus for an important reason. One of the mistakes I've seen people make is by not having targets is they end up in this endless loop of never getting done. They never get done because they don't have targets, so if their only goal is make it faster, you can always make it faster. And unless there are some of you in this room who do benchmarking for fun, and you know who you are, and we can meet separately and have a special meeting, you really want to do the least amount of experiments to get the most accurate data as quickly as possible. In order to do that, you need to know when you're done. Very important second point. Sometimes it's impossible to hit your goal. And if you don't know that, you may struggle for months to try and tune something that can't be tuned to where you're trying to go. Sometimes you have to throw things away and rewrite. And having targets and keeping track of how much time you're spending on trying to get to that target can make the difference between a one-year death march that never results in success and a quick turnaround where you realize, okay, architecture's got to change, move on. So here's an example that I would say is reasonably good in terms of setting precision. For this mythical web app that I've simplified, I'm going to say my total population of users on average is 10 million users. The request rate is 1,000 requests per second on average, but I also want to think about what peak is. Now, there's often a debate. Do you tune for peak or do you tune for average? Now that I've taught you the two magic words, what's the right answer? It depends. It depends on whether you're okay with having idle capacity, which means when you tune for peak, you're going to have capacity sitting around, or if you're using something like auto-scaling where that capacity magically goes away, great. You can tune for peak, but use auto-scaling to make sure you're not paying for peak the whole time. But it's usually not simple enough to say, I'm just going to target 1,000. Another piece of advice from years of doing this, even if you've done a great job of architecting a system and you think it's really scalable, you really have to have defensive measures. What do I mean by that? Let's say that you set 5,000 as your peak. What happens if you get over 5,000? Do you want your app to fall over? There always has to be some limit, and you have to decide what the behavior is at that limit. Do you want customers to be turned away? Another piece of advice. If you simply say, we're busy right now, come back later, what do you think the average user is going to do? Again. I've actually seen this happen in production where an application had a bottleneck and we started throwing, please come back later. The request rate tripled. Because everyone said, well, later's now. Okay. So what I've done is built heuristics into how you tell someone to come back. You could say, come back in 4 minutes, 37 seconds. You could completely make up that number, or you could make up that number based on queue times or other things. But giving someone something better than just try again right now can help defer the impact of what happens when you get more than you can handle. But it's really important to prepare for that. Even in the most scalable architectures, you can always hit some sort of limit. And if you're worried about the end user's experience, think about how you handle that. You also have to think about concurrency in terms of on average, how many users are on at once, and what's the peak number of users I want to handle at once. This is really important because this 50,000 peak users at once is where you start saying, okay, after this, here is where we start telling customers something else to do. Now, here's my example of a workload transaction mix, where I have the mix ratio, what percentage of these different workloads are happening at a given point in time, and the 95th percentile, or you can pick 90, you can pick 95, don't use average, please. I could ask the audience what's wrong with averages, and probably a lot of you, since your experience, could do it, but I'll just fast forward. The problem with averages is you could have the average of 1 and 100 is 50.5, right? The problem is if you have a bimodal application where people either get 1 or they get 100, and 100 is really bad, that means 50% of your people are really happy and 50% of your people are really pissed. And average doesn't cut it if you care about how the people using your systems are getting, what experience they're getting. Yes? Well, the question was, why have request rate and peak user? You could apply this request rate at peak, or you could apply this request rate, at average, right? The important thing is the combination of this workload mix and the request rate. You could do either. Okay, quick trivia question. Who knows what this is? What's that? It is on the way to, it's within 60 miles of here. I will give you another hint. It's in Primm, Nevada. That's right. It's a generator. And I'm talking about load generation, so I thought it was cool. I drove by that the first time and said, wait a minute, did I get into Area 51? Is this? It's really, these are the collectors around all the ground are mirrors, and the mirrors shine on the collectors. There's water, turns into steam. We can now run our hair dryers. My pressure was over 3 milliseconds. So how to generate load? I have to tell you that relying on humans is really unpredictable. If you need repeatable tests, don't use humans. If you need some lightweight test, using something like a Mechanical Turk is a good idea. You can have lightweight scripts. But it's really not good for load testing because humans just aren't very predictable. You can use synthetic load, and there are lots of ways you can do that in the web environment, JMeter, Suspension, open source. There are lots of commercial tools. But doing good performance testing starts with generating good load. And good load means it's something you can both set how much load you're getting, you can set what type of load, and it's instrumented in a way that matters. You could write your own. I can tell you, having done this, more than 10 times, it gets pretty easy to write load generators all the time, but it's really a hassle, and there are plenty of good tools out there. So in general, you should be able to find something, whether it's built into a benchmark that you use, whether you rip it off from a benchmark that already exists, or whether you write your own. I would prefer to start with something that works. So, how to measure? There are lots of ways to measure. The best thing is to have metrics built into your load generator. You can, another thing people may not realize is you can add your own metrics into CloudWatch. So you can get a combination of CloudWatch infrastructure metrics and your own application metrics, which it's nice to see them all in one place rather than to either have to cut and paste or look at side-by-side diagrams. Yes. They really are helpful. Please, although I'm not a statistician, if ever you're going to report a number, please don't just report average. If you're going to report a number, report average and some measure of variability. Whether it's a percentile or whether it's standard deviation, average really doesn't mean much. CloudWatch metrics, I actually have a slide on that, so I'll give you a little, if you haven't been using it. Adding instrumentation. There are lots of ways to add instrumentation. Sometimes when it's code that you own or code that you have access to, simply putting in debug statements that have a timestamp can help you pinpoint, especially when you're saying, what the heck's going on here? If you can't get the instrumentation from the infrastructure or from the load generator, sometimes you have to add it yourself and have you add your own debug statements. You can use a stopwatch. I've actually had to do that in critical situations, and it's crude. It's really hard to get precise, but if you got nothing else, okay, it works. You can use log files, but I have to tell you, log files have a problem. This is a slide I used yesterday, but I'm bringing it in here for a point. Before DynamoDB released, I was asked to validate some of our performance claims around it. And one of the things I found, having not used it before, and this is when it was brand new, was initially I was setting my load generation to a certain level and I wasn't getting that load. I knew that meant a bottleneck. I didn't know what the source of that was, and I started doing some debugging with debug statements and that sort of thing. What I found was the default logging level for the SDK before it released, or right when it released, was debug. That meant that every statement was traced, all of the packets were traced. There was a ton of stuff. I was lazy, and to use the least number of clients, I was using CC2 8x larges for my clients to generate. I needed to generate 100,000 requests per second, so I needed some beef. They have lots of processing units, and that meant I could run lots of threads. But the problem when you run lots of threads and they're all trying to write to one file is this picture. The orange line is what happens when the bottleneck becomes the log file. And one of the main reason I have this graph is a lot of times when people start turning on logging, some people try to relate this to physics and the Heisenberg principle and the act of observing, screws things up. But the real issue is that you want to have the simplest environment you can. You want to have the most realistic environment. And if you're running in production with debug, great, turn it on. Just realize that's going to behave differently than running with sort of normal trace. I won't call this a commercial, but a lot of people don't really take advantage of CloudWatch. CloudWatch is free at I believe the 5-minute granularity, and for a fee you can get the 1-minute granularity. But the cool thing is it keeps 14 days of metrics even after you terminate an instance. Those metrics can stay around. They give you cool graphing. You can create alarms so that you can actually do things when your concurrent users go above 50,000 and you need to decide to turn on the please come back later heuristic mode. But some tips. When you start using it for the first time, CloudWatch uses universal time. And for instance, this bit me, okay, so I'm admitting it. The first time I was running instances in US East, I wasn't in US East, and I wasn't realizing the time frames I was looking at were all wrong because CloudWatch was doing it in UTC, not US East, or my time zone. So that's something to watch. And also, there are a number of different stats types you can get, min, average, count, etc. You need to pay. You may not notice that, but it makes a huge difference over what you're looking at, whether you're looking at an average or a count or a max or min. Yes? It isn't, and it's something I've had a conversation with that we should really add that. So I know that the CloudWatch team has my request, and it's something we're working on. Right, someone mentions, pardon? No, but I have friends. Okay, just a personal aside. It turns out that the owner for CloudWatch used to work for me at another company. I was her first boss. So she owes me. Both. So when you're doing end-to-end testing, you need to, I can't stress this enough, you really need to trust and understand the tools that you're using, because sometimes the tools you're using to test can have bottlenecks, and you really don't want to measure the tools. You're trying to measure the system under test. So make sure you really trust the tools that you're using. Using realistic data is a thing that's often missed. What I mean by realistic data, in my previous example, I said a user account, a population of 10 million. What do you think happens if you're doing performance testing and you have 10 sample users in your database, and in production you have 10 million? Will you have an answer to your test? Yes. Will that answer be particularly useful? No. So people often miss making sure they have realistic data both in scale and distribution. What do I mean by distribution? Take our example, if we have new users signing on and then we have signed in users. If your data is populated with only one type of user, you won't be able to generate the right kinds of customer profiles or end users, and that skews your results. Another common mistake, I've seen a lot of junior engineers do this. When they measure time, they simply start running a test, they wait till the end of the test, and they just use all of that time. If you're doing a test of large scale, it takes time for all of your tools to ramp up. For instance, if you're doing a test with 100,000 end users, and each of those users is simulated by a thread, it takes a while to spin up 100,000 threads. Unless you're trying to measure the performance of spinning up 100,000 threads, you need to use the notion of ramp up, which is when all of your stuff is getting ready to go. Steady state, which is at some point in time you declare the test is now on, Think of it as in the race, in car races, they have a running start, so they get all the cars out on the track, and once they're all out on the track and everybody's running and everyone's in their lane, then they do the flag. That's sort of the ramp up and steady state. I use ramp down too because sometimes there is a behavior at the end of a test where threads are dropping off and you can get some weird decay. And so I used to sort of take the good bits. So slice off the ramp up, slice off the end, and use just the good bits in the middle. If your tool doesn't support that, you're going to have to figure out what time slice to use. I like to build it into my tools. Choose a reasonable test duration. I can't tell you how many times I've seen tests where a developer would say, well, I ran this test for 15 seconds on my desktop, so I'm estimating the mean time to failure is 1 year. Right. The term leap of faith comes to mind. You really need to use reasonable durations. Now, how do you do that for availability? Obviously, if you're going for a 99 percentile or 5 nines or whatever it is you're trying to do, the ideal thing would be to run for years and then say, here's our result. You don't always have that. The longer you run it, the better. One thing I like to do, and that's one thing that's really good for AWS, you could get a scaled down version of your system, put it up, and leave it running a long time. Scaled down means you're not paying for full production costs, but just leave it running. And things like memory leaks and handle leaks and all those things could show up if you leave it running for 5 months. Run multiple tests. You never measure something once. A classic example, you measure something twice. You have 2 different numbers. Which is the right answer? Nobody knows. So you run it 3 times. You get 3 different numbers. Which is the right one? You don't know. You have to run it enough times that you're comfortable that you have an understanding of the average and the deviation, and you choose which you're going to use. You can use statistics to say, I want to use the thing that 95% of the time people are going to get, and that's typically going to be a more conservative number, but it's one that you know you're going to get most of the time. Quick tips on using ELB. These tips are from a white paper, the Elastic Load Balancing. A couple of things. You can pre-warm the load balancer. And in pre-warming it, you can have a number of instances already up. You can also look at things like the time to live data. You really need to ramp up at a realistic rate, or what you may end up benchmarking is ELB's ability to react, and that may not be something you're trying to measure. You also want to monitor errors while doing this, so that you're making sure that you are measuring healthy hosts, and you want to look at error codes like the 200 to 500 range, and whether you're actually getting errors, some sort of error back from ELB. Finding bottlenecks, one of my favorite topics. I had a conversation earlier. Bottlenecks, finding them is kind of an art with a little bit of science thrown in. The first thing I always do when I'm trying to find a bottleneck is first look for clues. Let's say hypothetically your target is a 5-second response time. You're looking for something that's a good chunk of 5 seconds. And so anything that gives you granularity in the same unit that you're trying to tune helps to start identifying things. If you don't have enough clues, then you start adding instrumentation, and then you also use isolation. Isolation is my favorite technique. What does that mean? If you have a complicated environment and you want to, for instance, stub out everything but the web front end, then you can at least know, out of 5 seconds, what does the web front end take? I've actually got a picture on that, so I think I'll walk through that quickly. So in this particular case, you could literally copy your app, stub out all calls to databases, anything that's just not related to front end, and run your end-to-end tests and only measure what happens at the web layer. You could isolate what's happening at the app server layer by not going through the web interface and only directly calling the app layer. You can do the same thing at the disk level by either stubbing out everything in front and just making calls to the things that use disk, or you could do separate tests using standard benchmarks on the disk infrastructure. As an example, let's say that you're trying to find a bottleneck. You look at disk stats and you see that you're getting 500 IOs per second, and you want to do some tests to see how much capacity does your configuration have. And if you can't get more than 500 IOs per second, that probably means you've maxed out your IO, and that's a good place to start looking for fixes. So you get the idea. You can use this on any of the layers. You can isolate things like S3. You can isolate database. Standard benchmarks are a great tool when you want to drop down to isolation, simply because in a lot of cases there are things out there that will help you test at a more granular level. The thing about standard benchmarks is there's still some work to be done. Most standard benchmarks require some amount of tuning, whether it's tuning the Java VM settings, whether it's tuning the disk I/O infrastructure. It's rare that you can just get a database tool or some other tool, run it, and say, oh yes, these results are fine, I'll use them. There's some amount of tuning to make sure you trust the results. You often need to automate them so that you can run them reliably and repeatedly. Okay. Most importantly, if you run these tests, how do they relate to what you're trying to, what do the results do in answering your question? And how close is the implementation of this benchmark to what I'm doing? Here's an example. Let's say that you are testing disk I/O, and you normally have some sort of RAID architecture for your I/O. You can construct tests, and I'll show you some examples of that, where you're using multiple drives simultaneously, but you're not doing it with RAID. And in that situation, you may get results that will say, with the best RAID in the world, this is what I could get. RAID is going to take something away from that. But you have to be able to relate the technology of your test to the thing you're trying to measure. So I am going to give some examples of how to run specific tests. That doesn't mean I'm saying, yea, verily, I endorse these tests, you should only use these tests, or these tests will work for you. I'm just picking some common examples, but first I have some common questions that I get asked, and since a lot of times I end up being asked to answer these questions, I figure with a captive audience, I can pre-answer the questions, and then you'll help answer them for other people, and then I won't have to answer them as often. So those questions, I'll just go through them rather than reading the slide to you. So an ECU, how many people know what an ECU is? How many people want to know what an ECU is? Okay, I'll spend time on the slide then. So an ECU is a really simple metric we came up with. The origin of an ECU was originally when EC2 first started, we had a very simple offering, and when that offering went to more than one, we needed some way of saying, how do these compare to each other? So we came up with a definition. This definition happens to reference something that was similar to a 1.2 gigahertz 2007 Opteron or 2007 Xeon processor. You may say, my God, does that mean AWS is running on these things? No, it doesn't mean that. But at the time, it was what we used to help people understand what the unit of one meant. The really important thing, you can see this table, we provide an ECU rating for all of the instance types. The purpose of that rating is to help you understand the relative compute power of those instances. Your mileage may vary. It's a very simple measure, and it's just there to help you choose to understand a little bit about the compute capacity of the instances. If you are going to go out and test CPU on your own, there are a number of ways to do it. I would choose a test where you have access to the source so you can really see what it's doing. And if you wanted to derive your own test from it, you can. And also where the test is automatable and repeatable. I'm going to go through Spec CPU because it's sort of the granddaddy of all CPU tests. It's been around a while. It's got a very detailed set of workloads. The integer side has, I believe, 12 different workloads. The floating point side has 17 different workloads. All of these workloads actually evolved from originally some real workloads, but they've been trimmed down to be able to be agnostic to the platform and to be automatable and so on. The important thing is, too much pressure. The important thing is that it runs each test 3 times, and it does a good use of statistics to come up with the geometric mean of those results. Ultimately, you end up with a number. The good news about spec is if you have a spec result, then if that spec result is 2 times higher than some other result, that means for this set of tests that test with the two times higher result is 2 times faster, because it simply measures time. So if it's a higher number, that means it's faster. Some tips and tricks if you are going to try and run spec on your own. First, you can always go to the spec site to look at results that are there. Almost all of the results are published using the Intel compiler. If you happen to try and use the GCC compiler, the Intel compiler is about 25% faster. One of the other things you might read in the small print is they almost all use SmartHeap, which happens to be a very high-performance, multi-threaded memory manager that just applies to the C++ tests in the integer test, but it makes about a 10% difference in the overall number. There are sometimes a confusing set of different results. I suggest if you're going to look at this, you understand what the different results types are and how to use them. Okay, memory testing. I want to speak briefly on this. You can use Stream as one of the tests that I think is very popular. It actually has 4 different workloads. It's important you understand this test. It does provide scaling tests, so it increases the number of threads, and theoretically, if your tests are scaling, you will get higher throughput numbers for the memory. One challenge I've seen is that sometimes you end up measuring the level 3 cache and not the memory, and you need to make sure you tune the parameters so that you have enough memory that you're not getting things out of the CPU cache. Another topic, I/O ratings on EC2. Some people find what we talk about is very confusing. In EC2, we provide virtualized instances. On those instances, there are shared resources and dedicated resources. CPU and memory are dedicated. Instance storage is dedicated, but network I/O, meaning both network and network disk I/O, is shared. The I/O ratings refer to those shared results, and there are a couple caveats to this, that if you use an EBS optimized instance, that means that we've dedicated bandwidth for EBS traffic, and so you're going to be able to isolate the network traffic from the EBS traffic. And also, when you use cluster compute instances, they have very high performance and low latency in between cluster compute instance types. If you're trying to look at network performance, there are really 2 types of network. There is instance out to the internet, and there is instance to instance, and it's important to separate those 2 if you're going to measure. If you're going to, I'm going to skip ahead to get to some slides because I promised you I would do that. If you're going to test disk I/O, then it's important that you look at a couple different variables. First of all, there are different write types, write versus read, and you can do mixtures of both depending on what you need. But it's usually important. I like to measure them each separately and then together. And then you can also look at random versus sequential I/O. You should always look at queue depth. So here's a graph that I prepared using FIO, which is a flexible I/O test framework. And I was using these tests to measure provisioned IOPS at 2000 before that released. A couple things I wanted to point out. This chart gives you separate latencies for read alone, write alone, read, write mixed random, and read, write mixed sequential. And that granularity of data can help you answer lots of questions about disk performance. The other thing I did here was I ran 1 disk, 2 disks, and 4 disks to see what the latencies were. This graph is in microseconds. So you can see the tallest orange line there is running in at about 1,000 microseconds. But I mentioned this point earlier. If you're using RAID, there is overhead with using RAID. Using this approach, you can measure the overhead, the throughput and the latency for multiple disks without the overhead of RAID, which means you're going to get worse performance with RAID, but at least you know what the best possible is. Yes?
So once you get these results, what do you compare it to that's acceptable? What's acceptable for your system?
The question is, how do you use these results to determine what's acceptable? It goes back to what your target is. If what you're trying to figure out is a bottleneck, and you have to figure out how much time you can allow for disk I/O.
What if you flip it, and say, I don't have target initially, I just want to take a snapshot of the system and see are my numbers that I'm getting acceptable to, say, standard practice?
Okay, the question is, how do I know that this number is good enough? What you do know is this is your baseline. You can also measure variability and say, do I get this repeatedly? The question is this good enough is a tougher one that it would take a lot more questions for me to say, how you could determine it's good enough for you. If you want, we can talk about that more after because I'm running low on time. So I want to show you another graph here. This one is an important point. This is the same test, but in this test I'm comparing a Q depth of 1 to a Q depth of 2 with provisioned IOPS. Why does that matter? Remember my comment earlier about being careful measuring provisioned services? For this particular set of tests, a Q depth of 1 was able to achieve 2,000 IOs per second. What do you think happens if I try to do more than 2,000 IOs per second? A, I won't get more than 2,000 IOs per second. B, my latency is going to increase. This graph shows you the cost of running too high a Q depth on latency. I want to show you some graphs in the time that I have left on testing databases. There are many tools out there. One of the ones that I've used recently is the Yahoo Cloud Serving Benchmark. I happen to use that because I had about 2 weeks to test DynamoDB before it first released, and I had never used DynamoDB before, and I didn't have any tests. And this particular open source test had everything I needed to put some tests together quickly. And in terms of all the things you need, it has load generation, workloads defined, extensible framework, metrics, reports built in, so it was good. That was too fast. This is an example of the default workloads where it gives you 50% read, 50% write, 95% read, 5% write, et cetera, et cetera. So this is a great starting point if you have nothing already. This is an example of the sequence. You run a sequence of workloads in a particular order because some of the workloads add records which can change the results, and if you want results to be repeatable, you have to run the tests in the same pattern every time you run them. Well, let me get to the data. Okay, so this is I remember I said earlier that DynamoDB provides single millisecond service-side latency. This is actually a diagram of client-side latency running at 100,000 requests per second with a table with a billion items in it. Each item is about 1,000 bytes, so it was a terabyte of data. Running for over an hour. This histogram shows the latencies, the buckets for the latencies. And you can see that all of them are clustered. 95% of them are actually below 10 milliseconds, which I'd say would qualify as single-digit latency. The interesting thing is the graph looks fairly simple when you do this at 25,000 requests per second. This is with workload A, so this is actually 50% read, 50% write. I have a test result for 95% read, 5% write. I want to get to the next one, which is if you want to do this yourself, use YCSB version 1.4. We built a DynamoDB plugin for that release. It comes when you download it. A couple things, hints. Because of assumptions that DynamoDB was tuned for, DynamoDB is tuned for a uniform distribution. Some of the defaults, some of the workloads in YCSB have non-uniform. They're called Zipfian, where 20% of the data is repeat data, so it creates hotspots. If you do YCSB testing with hotspots, you're likely going to need to provision because you could run into throttling if you get over the provision level for certain parts of the system. The CloudWatch stats really help, but this is an illustration of what happens when you're running Zipfian versus uniform. DynamoDB is tuned assuming equal distribution of keys, and when you use an unequal distribution of keys, keeping the same request rate, you can run into different performance behaviors. In answer to the question, does DynamoDB scale? You can see these tests are for 10,000 RPS. Same thing, horizontal axis is millisecond response time. There's 25,000, there's 50,000, there's 100,000. So you can see, I would say for this set of tests, for this workload, that it scaled pretty well. Interesting question. What's the cost of doing these tests? Well, I would like to make the point that one of the things you can do is test things in parallel. So if you ran these tests serially, it would take about 171 hours to run those sequence of tests I just showed you. However, if you provisioned for 100,000 and ran them the 10, 25, and 50 all at once, and then the 100,000, it cuts the runtime down to 99. And if you're provisioned at 200,000, the total time would be the largest number, which would be 74. So you can really play with that if you need answers faster. The last thing, I'm out of time, so I'm going to just show you this one last slide, which is which instance type should I use? There are lots of things that go into that, and you can throw "it depends" back into me. But you want to simplify down to the things that matter. How many processors? How much memory do I need? Am I doing lots of I/O? Looking at cost performance is important too. So I like to take the cost of an instance and divide that by the performance of an instance for a given test, and that gives you a great measure. So I've been talking a lot, and I am out of time officially, so I will take questions unofficially down here on the stage. Please remember to fill out surveys, and I have M&Ms to get rid of, so I will put the dispenser and you can take